Okay, so solving absolute value inequalities. So let's jump right into an example. Absolute value of 2x plus 1 is greater than 5. Okay, so just like yesterday, what was our first step yesterday? Right, absolute value is by itself, same thing here, okay? The absolute value is by itself. Once it's by itself, I look at the symbol here, and I say, okay, what symbol is this? This is a greater than. Is greater than or and? Or. Okay, so I put an or. That way in the end, that's what I'm looking for. Okay, and then we split it up exactly like we did yesterday into two equations, or inequalities in this case. So 2x plus 1 is greater than 5. And then 2x plus 1. Now, instead of just doing an equal sign, since I'm changing it to a negative, I have to flip the sign, and then I put negative 5. Okay, so don't forget to flip your sign. This one is greater than, this one switches to less than.
You have to flip your sign whenever.
Yes, because I'm making this negative, so I flip the sign here. Okay, so let's solve for x. How do I solve for x? Subtract the 1. So 2x is greater than 4. Divide by 2. X is greater than 2. Same thing over here. Subtract the 1. 2x is less than negative 6. Divide by 2. X is less than negative 3. Okay, if you don't remember this part, like you don't remember it's an or, it's okay. Just do a little graph. So let's just do a little number line of this and see where our numbers fall. So we have negative 3. I'm going to put 0 on there, and then positive 2. Are they open or closed circles? Open. So negative 3, I'll start over here. Negative 3 is open. Is it shaded to the left or the right? The left, right. This is kind of acts as an arrow, so pointing to the left. And then positive 2, open circle, shaded to the right. So because they're split, when they're split like that, that's your or statement. Okay, so this is my final answer. I think on your worksheet you're graphing also, so that's all you're doing for graphing. If you're still unsure, you can check an answer. Okay, so I could plug in, like over here, I could plug in 5, something bigger than 2, check it. Over here, I could plug in something less than negative 3, so smaller, like negative 4, negative 5, and check it. And then if you wanted to, you can put something in the middle, make sure it doesn't work. Okay, that's what's nice about equations and inequalities. You can always check your answers. Okay, let's do another one. Yes.
How would you check that?
So we'll check. Okay, so let's check something in this solution set. So if this is 2, I can't use 2, but I can use something bigger than 2. So I could use, let's use 5. So I'm going to put 5 into the x, and I want to see, is that greater than 5? So 10 plus 1 is 11. Absolute value of 11 is greater than 5. That's all I have to do. And if you have 2 sets like this, I would check probably both. So this is negative 3. Make sure you pick something less than negative 3, like negative 5, negative 6. Any other questions on that one? You mean from right here?
Yes.
Yes. So when you split up your two equations, one should be a greater than, one should be less than, whether you start with less than and then switch to greater than, or vice versa. You always are going to switch. No, it doesn't matter. You just always switch. Okay, so number 2. Absolute value. Hey, you guys, my speaker is back there by my computer, so all of you people chit-chatting, it picks up you and not me. Okay, so absolute value of negative 3x less than 27. Again, if you can't remember it's a less than, come up with something. It looks like an L. You know, make it an L. That's what it looks like, a less than symbol. Something to remember. Oh, that's a less than. So because it's a less than, is it going to be or and? And. Okay, so I just kind of put that off to the side. right? The absolute value is by itself, so I don't have to do anything first. I'm going to go ahead and just split it up. So negative 3x is less than 27. I leave that one by itself. But then this is the one where we're going to switch. So negative 3x, flip the sign, and flip the sign of this number. Negative 3x is greater than negative 27. Okay, how do I solve for x on the first part? Divide by negative 3, and what has to happen? Yes, flip the sign. So this flips, so now that actually says x is greater than negative 9. I'll put my and in there so I remember what to look for at the end. Same thing here, divide by negative 3. X is less than positive 9. And let's graph that so we see what it looks like. So we just have negative 9, we'll do 0, and positive 9. So this is how you verify if you're correct or not, and your symbols are correct. We said this should be an and. So when I put these on here, they should go towards each other. So at negative 9, I have an open circle going to the right. At positive 9, I have an open circle going to the left. Okay, so because they go in together, that is my and situation or scenario. Do you remember how we write our answer when it looks like this?
Yes, put x in the middle.
Yes, put x in the middle. So I start on the left. Negative 9 is less than x, and x is less than positive 9. So that's how we write our and scenarios. You have a beginning number and an ending number. X is in the middle.
Can you write like that as your answer, or can you write it like that?
This is how you'll see it on any test, quiz, standardized testing if it's and, so I would go with that one.
That's always for the and statement?
Yes, or you cannot put together. So you should never put, if you have an or statement, you should never put those together. It should be separated because it's two separate intervals. And is one interval together.
Will the, when writing it like that with x in the middle, the sign will always be
Open to the right.
They will
Yes,
always be.
because you always go from the smaller number to the larger number. So this is the smaller end opening to the larger one. And then x is the smaller one, 9 is the larger one.
And then if it's 4, you just
Right, you'll have two separate ones. Yeah. Okay, number 3. Absolute value of 2x minus 4 plus 16 is less than or equal to 24. Okay, do not choose if it's less than or greater than until you have isolated the absolute value. Okay, just like yesterday, we didn't split them up until we isolated the absolute value. So we're going to do that first, just in case the sign changes. So how do I get this absolute value by itself? Perfect. Subtract the 16. So this doesn't change the sign, but sometimes it does, and we'll look at those. So less than or equal to 8. So I see a less than. Less than is what? And or? And. Okay, and this is just going to help us check in the end that we have our answer correct. So then go ahead and split it up. 2x minus 4 is less than or equal to 8. 2x minus 4 is greater than or equal to negative 8. Make sure you flip the sign over here. And then go ahead and solve for x. So once you get your answers, then graph it on your number line, and then that can help you see, did I do my numbers correctly? Did I do my signs correctly? I can't So -2 is a closed circle going to the right. 6 is a closed circle going to the left, and so then they meet in the middle.
Oh, dang.
Yeah, you could definitely draw one dotted line. If you see that, oh, I know it's going to go this way, yeah, one solid line is fine. And then, of course, our answer, instead of leaving it like this, we put it together. -2 is less than or equal to x, and x is less than or equal to 6. Put it all together. Okay, let's do one with a little fraction in it. I know. Horrible fraction. Okay, make sure you get all that. It's absolute value of 2x minus 1 divided by 6 plus 2 is greater than or equal to 5. So go ahead, I want you to isolate the absolute value. So get the absolute value by itself. Yes.
What was the question?
Ethan?
So do we have to get rid of the 6 on the bottom as well?
Yes, but you would do the 2 first.
That was my question.
Okay, so first subtract 2, then how do I get rid of the 6? Multiply by 6.
Would that change anything in the absolute value sign?
No, not at all. Absolute value is kind of like, can't really touch anything on the inside until you go to solve for it. So subtract 2 and then multiply by 6. Remember, all that does is this 6 and this 6 cancel. Don't try to distribute in the absolute value. So absolute value of 2x minus 1 is greater than or equal to 18. Okay, so I look at my sign here. I have a greater than symbol and or. So then we can solve. 2x minus 1 is greater than or equal to 18. 2x minus 1 is less than or equal to negative 18. This one gives you some icky fraction.
I don't like it.
You don't like it? Actually, they're not horrible because they're just halves. Okay, so the reason I put or up here is because then when I get to my answer and I put it on my number line, I know that or should be pointing away from each other. So when I graph it, if something's not right, then I messed up a sign up here. So I have negative 17 over 2, 0, and 19 over 2. So I see that negative 17 over 2 is less than, so it goes to the left. 19 over 2 goes to the right, and so then I see that it's an or, and I'm good to go. And this one we write just separately. You can switch the order on that if you want, it doesn't matter. How are we doing?
Well,
Okay, now we kind of have the weird ones.
why you gotta switch it up?
Why do I have to? You're not that weird.
I was doing great.
You're not that weird. So before I do the next example, let's look at something like, oops, if I had this. Yesterday we did an absolute value equation equals a negative. What happens here? No solution. Why? Right, I can't ever have a negative in here. Okay, so when you're doing inequalities, same thing. If you see a negative on the right-hand side, something is going to happen. Okay, it's not going to be normal. So our next example, yes.
Why is that no solution?
Why is this no solution? Because absolute value is a distance on a number line. So from 0. Right, you can't have negative distance. So I can have two solutions, but that distance is always going to be a positive number.
Okay.
If you have a negative over here, right away I can say, oh, no solution. If you forget that, you can still solve it, get your two solutions and plug it back in and see that either of them work. So you can still do the work. It's totally fine.
Okay.
Okay, so this one, absolute value of 4x plus 16 greater than 8. What would you do first? Subtract 16. So absolute value of 4x is greater than negative 8. So when you see a negative here, you have to know to yourself something is going on. It's not going to be a regular problem. I don't even do the and or here, okay? Because I see this negative, so I know something's going to happen. Okay, so let's look at a number that I could put in here. Let's say I put in, I don't know, let's say I put in 2. 4 times 2 is 8. Is 8 greater than negative 8? Yes. Give me another number that would work in here. 1. 4 times 1 is 4. 4 is greater than negative 8.
All real numbers.
Ah, all real numbers. Why is it all real numbers?
Because anything you put in.
Perfect. Anything inside this absolute value, when you bring it out, it's always what? Positive. A positive is always greater than a negative. A positive is always greater than a negative. Positives are always bigger than negative. So any number will work. If you were doing your number line, you would graph literally the whole thing. But your solution is all real numbers. So when you see a negative, when the isolated absolute value equals a negative, or is greater than a negative, or is less than a negative, something is going to happen that's different than your normal solutions. Yes, we're going to do less than right now. So if this is greater than, I would do this. Plug in some numbers if you want, and see, okay, positives are bigger than negatives. That's always true. So then let's do a different one. Yes.
How we going all the way to the left? If you can't plug in, like, that'd be 0 right there.
Like if I
We
zero.
don't have to solve, like, yeah.
So if I put, well, it doesn't matter what you put in. So if I put a negative in here, negative times 4 is going to be a negative number, but that absolute value of a negative will be a positive. So it doesn't matter what you put in. Yeah, it's anything you can put in there will work. Okay, so then this is the last one. Negative 6 times absolute value of x plus 3 greater than 30. All right, what would you do first? Divide by negative 6. What's happening when I divide by that negative 6?
Flip the sign.
Yes, flip the sign. So absolute value of x plus 3 is less than negative 5. I see a negative, so something is happening. Something weird is going to happen. So what's a number less than negative 5? Negative 6. What else? Negative 7. Can I ever get a negative from an absolute value? No. A negative. What? Oh, sorry. This is what I wanted to say. No, I don't want to say that. Okay. Can I ever get a positive? Oh my gosh. Can I ever get a negative from an absolute value? You said no. So what is our answer here?
No solution.
Yikes. That was like, I don't know what was going on. Sorry.
Because I called it, I was like, that's no solution.
What do you mean? This one up here? Okay, so this one though, look. If I put a number in here, every time I have an absolute value, I'm going to get a positive number. Positive number is greater than negative. So here, if you want to write it like this is what I think I was trying to write. I'm always going to get a positive here. A positive is never less than a negative. So this is what's happening, but that can never ever be true. That's what I was trying to write. It just was not clear. A positive is never negative. Oh my gosh. Never less than a negative. I'm done. I'm done. I'm going to stop my video because that's